In this video we're going to prepare desoxybenzoin, or 2-phenylacetophenone, an interesting aromatic ketone. First of all, measure out 3.5 grams of dry benzoin. And then measure out 30 ml of toluene, which we've chosen as the main solvent for this reaction. Set up a 100 ml flask equipped with magnetic stirring. Note that we won't be needing heat for the reaction, though. Add the toluene to the flask. Our reducing agent for this reaction is hydrogen iodide, which we create in situ by reacting iodine and red phosphorus. So weigh out 7.5 grams of iodine and add this to the flask with stirring. The mixture will turn dark red and not all the iodine will dissolve. Now measure out 0.6 grams of red phosphorus. This will react with the iodine to produce phosphorus triiodide, which will then react with the O group in our benzoin to form the iodide. Add the phosphorus slowly to the stirred mixture. You'll see the red color intensify, and the iodine will dissolve and react. At the end of the addition, the mixture will look like this. Leave this stirring for 15 minutes and allow to react. Now it's time to add the benzoin to our phosphorus triiodide solution. Carefully add all the benzoin into the flask. Now leave the mixture stirring for a further 10 minutes. Now weigh out 1.3 grams of liquid pyridine and dissolve this in 10 ml of dichloromethane. Add this slowly to the reaction mixture. As you add, you'll see a white smoke being generated, and the mixture will heat up. Once addition is complete, leave the flask stirring at room temperature for 3 hours. Okay, here we are 3 hours later. Not much seems to have changed. Measure out 15 grams of sodium thiosulfate crystals. This is the pentahydrate salt. Add 30 ml of water and stir in order to make up into a solution. Then add about half of this to the reaction flask. Stir the mixture well, and remove any residue from the sides of the flask. Then pour the flask contents into the remaining sodium thiosulfate solution. Stir well and break up any solids, and you should see the iodine color fade away. Once the mixture is a pale color, set up for filtration and filter the mixture. The very fine sulfur particles may make this a little slow. At the end you can see there's a little bit of red phosphorus remaining, but not a lot. Pour the filtered reaction mixture into a separating funnel. There should be 2 layers, the top being the organic one. Separate off the bottom aqueous layer and keep it. Then separate off the top organic layer into a flask. Pour the aqueous solution back into the funnel. And then extract this by shaking with 20 ml of dichloromethane in order to make sure we've got all the product out. It takes a bit of time for the layers to separate. Drain off the bottom organic layer into the flask containing the toluene solution. Then add some anhydrous magnesium sulfate to the organic solution in order to dry it. Decanter filter off the magnesium sulfate. We chose to filter through some densely packed cotton wool. Now we need to evaporate off the DCM and toluene solvents. You could distill or simply boil off, as we're doing here. Do note though, if you boil off, the vapors are quite irritating to the eyes and skin due to the presence of alpha-iodo ketone impurities. First the DCM comes off, then the toluene at a higher temperature. Once the temperature gets to over 120 degrees, you're pretty much done, so allow the mixture to cool right down, and then chill for an hour. It should crystallize like this. We transferred the mass into a small beaker, and recrystallized, using boiling methanol. It took about 20 ml of methanol to dissolve everything into solution. And on cooling for a couple of hours we got crystalline solid like this. We filtered this off, and dried it on the pump. And here's our first batch of product, pale yellow crystals, which melt at around 50 degrees, so we're fairly sure it's Desoxybenzoin. We only got 0.4 grams however, so it's a low yield. We evaporated the mother liquor from the crystallization and did get a further batch of crystals, but not as pure, as you can see here. Altogether we're guessing about a 30% yield. There are a few other procedures for doing this reaction, so we'll experiment and see if we can find one which works better. We think there must be a way that doesn't use very exotic solvents.